Today we will begin notes on section 5.4, solving radical equations. First thing I'd like you to do is open up your journal to page 140. Here I'd like you to copy down the definitions of a radical equation and extraneous solutions. Then I'd like you to look at the core concepts, which is basically step-by-step directions on how to solve radical equations, and we'll follow these steps in the different examples ahead. Please read through them now. Step 1 will isolate radical only if necessary. Step 2, raise both sides to an exponent that's going to eliminate the radical, and then you'll solve your equation like you would normally. So now let's go over to the notes and let's look at example 1 on section 5.4. Let's begin with 1a, and step 1 is we need to get the radical by itself, so I need to get rid of the 2. So all I can do is divide both sides by 2, so now that the radical is by itself. Next, we need to get rid of a square root, and you can do that by raising both sides to a power of 2. A square and a square root will cancel each other out, solve x plus 1 equals 4. Then solve for x like you would normally, and you get a solution of x equals 3. You should always then plug in 3 and check to make sure your answer works. Now let's try b. First thing you want to do is get the radical part by itself. So we need to get rid of this negative 1 by simply adding 1 to the other side. Next, we want to get rid of the cube root by cubing both sides. A cube and a cube root will cancel, and you're left with 2x minus 9 equals 3 cubed, which is 27. You'll then solve for x like you would normally. First, add 9 to the other side, and then you can divide both sides by 2, and you get 18. Again, you want to plug 18 back into the original equation and make sure it's a true statement. You can look at the mind progress, try them if you'd like, otherwise we'll work on them the next day. Let's move to example 3. Again, step 1 is isolate the radical, which it's already done. Step 2, we want to get rid of the square root on the right side, so we're going to square both sides. Now on the left, I have x plus 1 squared. The square means I basically have 2 of these next to each other, and I'm going to have to FOIL. First, outer, inner, and last, and then combine like terms. So really, x plus 1 all squared will give me x squared plus 2x plus a 1. On the right side, a square and a square root will cancel, and I'm left with 7x plus 15. Notice I have an x squared in the problem. This is a quadratic. In all of chapter 3, we learned how to solve quadratics. We usually solve them by factoring, so I need to equal to 0. I'm going to subtract the 7x to the other side, and I'm going to subtract 15 to the other side. I now have an easy trinomial that can be factored into x minus 7, x plus 2. And then set each of those factors equal to 0, and we get solutions of 7 and negative 2. We definitely need to start checking these. Again, you should always be checking them. Let's check 7. I'm going to plug 7 in to both sides where x is. And if you notice on the left side I have 8, and over here 49 plus 15 will be 64, and the square of 64 is 8. That's going to work. Now let's try plugging in negative 2. Negative 2 plus 1 equals radical. I'm actually going to stop here. Because on the left side I'm going to have negative 1 equals some kind of square root, and right away we should know that a square root or an even root cannot equal negative, so this one will not work. So negative 2 will not work. So it's only x equals 7. Notice we had an extraneous solution here. Now let's look at part B of example 3. Notice we have a square root on both sides. So we're just going to go ahead and square both sides in order to get rid of the radical. A square and a square root cancel. I'm left with 2x plus 8 on the left, and on the right I'm left with 3x minus 6. This is actually pretty easy. There is no squares. You can just move your x terms to one side, add the 6 to the other side. X equals 14 will be my solution. Don't forget you should, again, plug 14 in to both x's to make sure that it works, and I believe in this case it will. Let's move on to example 4. Notice we have 2 radicals in this one, and we can't really get one of the radical by itself on the left. The one on the right is already by itself, so we know how to get rid of that by squaring both sides. But on the left, the radical and the square just can't cancel because of this plus 1. What you have to do is write this one out twice. And we're going to have to actually show the FOIL on this one. This one's a little bit trickier. On the right side, the square root and the square will cancel. So on the left, let's FOIL. The radical x plus 2 times a radical x plus 2. Yes, the radicals will cancel, and we're just left with x plus 2. Next, I have radical x plus 2 times a 1. So that's radical x plus 2. Now the inners, 1 times radical x plus 2 is radical x plus 2. Then 1 times 1 is 1. I'm going to combine like terms, like the 2 and the 1 can add, and the 2 radicals can add together. Now, I'm left with a radical still, so I want to get this radical by itself so that I can square it again. So when I have these 2 radicals and I can't get them by themselves, I'm going to actually have to square 2 times. So that's your hint on this one. We're going to have to square twice. So let's get this one by itself. I'm going to subtract this x, and I'm going to subtract this 3 to the other side. After subtracting that, I can then divide both sides by 2 to get the radical completely by itself. So I'll have radical x plus 2 equals negative 1x. Now that this radical is by itself, I can now square the second time. The square and the square root will cancel, and negative x times negative x will be positive x squared. I have an x squared type of problem, which means I'm going to attempt to factor it. I'm going to move the x and the negative 2 over, and then I'm going to attempt to factor it. Factors of 2 are 2 and 1. And then I'm going to set each factor equal to 0 and get 2 answers, negative 1 and positive 2. And then quickly in your head, check to make sure that both of these will work. And it looks like one of them won't work. If you plug in negative 1 right here into the original, that will give me square root of 1 plus 1 is 2. So I do get 2 on the left, and then negative 1 on the right side. That one seems to work. Try plugging in 2. 2 plus 2 is 4. Square root of 4 is 2 plus 1 is 3. But right here, when I put the 2 in, I get 3 minus 2 is 1. So that's not going to be the same thing on both sides, so the 2 does not work. The next thing I'd like you to do is attempt the monitoring progress. Otherwise, we will look at them the next day of class. At this point, please list any problems that or any questions that you still may have.